Question number 14. Two traveling waves are moving through a medium. The diagram shows for a point in the medium. Okay. The variation with point t of the displacement d of each of the waves are shown. For the instant when t equal to 2 milliseconds. What do you mean by 2 milliseconds? It's at this point. Okay. What is the phase difference between the two waves and what is the resultant displacement of the waves? See, phase difference remains a constant throughout the waves. Otherwise, the distance between the two waves will not remain a constant. Okay. So therefore, if you look at this, the minima of this wave coincides with the maxima of this wave, which means the phase difference here is 90 degree. How do we know? Because when you write a sine wave, you know, if you write a sine wave like this is your 0, this is your 180, this is your 360. And the peak here, the angle here is 90 degrees, right? Phase angle. So therefore, see, this and this over here, they are differentiated by, they are different only by 90 degrees. The phase difference is 90 degrees. So definitely these two are incorrect. Now, amongst these two, we need to check which one is the right one. Okay. Now, one thing that you observe here, both of them are having minus 0.6. Sorry, here 2.6 and minus 0.6. Okay. So, you have two of these values. We need to determine it. Now, towards it, what we do is path difference, resultant displacement, not path difference, resultant displacement is asked. Now, what we do is let us take up the displacement of this wave with respect to the mean line. So, this is the displacement of the particle at t equal to 2 milliseconds. This is the displacement, right? So, which is equal to, how much is it? Which is around minus 1.6. This is minus 1.6. Which is for which one? Which is for this particular wave. Let me call this wave as A. Let me write this as XA. XA is equal to minus 1.6. Now, I want the displacement for the second wave, XB, okay, with respect to 2 milliseconds. At 2 milliseconds, now the particle here would have vibrated like this, and therefore the amplitude here is going to be 1 over here, 1 millimeter here, and minus 1.6 millimeter here, right? Okay, so therefore net displacement, the resultant displacement would be XA plus XB, which should be equal to minus 1.6 plus 1, which is minus 0.6 millimeter. Thus the right answer is option D. Okay, let us move on to the next one.